Good morning, student. Let's start today's class. Okay. Today we'll study about difference between vacuum tube and the semiconductor. Okay. What is the difference between, or what is the difference between vacuum tube and the semiconductor? Before that, we should know about what is vacuum tube. Okay. Before we discover the semiconductor devices, we use vacuum tube in the place of semiconductor devices. Okay, semiconductor devices means diode, transistor, resistor, etc. Okay, which use semiconductor. Okay, that which device use semiconductor at that place before at this place before time we use vacuum tube. An electronics device, vacuum tube. What is vacuum tube? Vacuum tube is an electronic device in which the flow of an electron is through vacuum is known as vacuum tube. That means in inside, since its name suggests or name refers vacuum tube, that means it used a tube which is vacuumed or which is airless. Okay, inside the tube the electron flow is happened. Okay, how the electron flow will happen, we'll see. A vacuum tube usually contains a cathode. Okay, this is cathode. This round shape, this is the cut section area or cutting area. Okay, this is rounded. Okay, and this is called cathode, and one is heater. Okay, in center position there is a heater, heating element or heater, and this collector emits electron. That is, it is also called electron emitter. That means this cathode, okay, emits electrons. Okay, and an anode. Okay, this is outer of the, here the anode is there. Okay, and also called plate. This anode also called plate. Okay, and also electron collector. That means it collect electrons which is emitted by the cathode. Okay, and one more electrode called grid. Okay, for controlling the flow of electron, and this grid is used to controlling the flow of electron which emitted from cathode and collected by anode. Okay, the electrode are housed in a highly evacuated glass envelope. These electrodes, okay, these cathode, anode, and grids, these electrodes are houses or are placed inside a evacuated glass envelope. Okay, the plate is provided positive charge. Okay, so that it emitted electrons are attracted to a plate. That means the cathode, sorry, the anode, okay, which is called plate, is provided by positively charged, so that it attract the electron which is negatively charged. Okay, in the process. Okay, the cathode is provided negative charged, so that it emits electrons. That means cathode is also provided it negatively charged. That's why it emits electrons. Okay, it provide electrons. Okay, and and the vacuum tube can be classified, or the vacuum tube can be classified into these four types: vacuum diode, vacuum triode, vacuum tetrode, vacuum pentrode. And vacuum diode is having two electrodes, and these four type of different vacuum tube is due to the number of electrodes. Number of electrodes means this is one electrode, this is two electrode, this is one, this is one, this is one. This number here 1, 2, 3, 4, 5 electrodes are there. So it may called vacuum pentode. Okay, because vacuum pentode have 5 electrode. Okay, so these four different type of vacuum tube is due to the number of electrode having the vacuum tube. Okay, and vacuum tube contain only two main electrode. One is anode electrode, one is cathode electrode. The vacuum tube has maximum 5 electrode or minimum 2 electrode. These two electrode are main electrode, which is called anode electrode and cathode electrode. Rest of the electrode are grid, which control the flow of electrons. There is also what 2 grid or 3 grid. The main Remember, the main electrode are two, anode and cathode. Rest electrode, if we consider vacuum pentode, there is 5 electrode. Okay, from the 5 electrode, two electrodes are two electrodes. Two electrodes are main. One electrode is for anode, and second electrode is for cathode, and the rest three electrodes are for grids, which control the flow of electron. Okay. Next we see the difference between vacuum tube and the semiconductor. From previous classes you already know that what is semiconductor. Okay, type of semiconductor, and the n type semiconductor, p type semiconductor, intensive, extensive semiconductor. Now the difference between the vacuum tube, which we will study today, and the semiconductor. Okay, different type of semiconductor. First we consider the size. The size of vacuum tube is very large because it is a glass tube, need large space, but the semiconductor is very small. The size of semiconductor is very small. Okay, because semiconductor, if you consider one transistor, that very small, 2 centimeter size. Okay, in about 2 centimeter. Okay, 2 centimeter, 1 centimeter, very small semiconductor size. Okay, if we consider the weight, the vacuum tube is very heavier and the semiconductor is very less. Okay, and vacuum tube is also fragile. That means it is not durable because it is made up of glass tube. Okay, in other hand, semiconductor is rocket. Okay, that means it is rough and steady. Okay, the operation of vacuum tube is very complex due to the presence of heating element. huh let's let's see the working. Okay, uh, first, when we uh, supply current or energy to the heater, the heating element heated. Due to the heating element heated, the cathode heated and it emits electrons. Okay, and these electrons shaped, or the flow of electron as the flow of electron is shaped by the grids. Okay, and these flow of electrons is collected by cathodes. Okay, this is the operation inside the vacuum tube, and this operation is complex because there is a presence of heating element and electrode and emitter and anode. Okay, but in semiconductor there is no filament or heating power required, or heating element are not there, so that the operation of the working is very easy. Okay, life period is short. For what? Vacuum tube is made up of glass, so that the durability or life period is very small. Both the semiconductor life period is very long. Okay. High power device. Vacuum tube is very high power device. Okay. But semiconductor is very low power device. Okay. Because in vacuum tube there is required of high power for heating element, but in semiconductor there is no heating element, so that low power device, it is a low power device because it required very low power. Okay. Next we today see the introduction of PN junction diode. Okay. What is PN junction diode? We have already studied about P type semiconductor, N type and N type semiconductor. In P type semiconductor, trivalent impurities added, and in N type semiconductor, pentavalent impurities added. Okay. In pentavalent example of pentavalent impurity is gallium, and the trivalent impurity example is arsenic. Okay, or indium. Okay, sorry, not arsenic, it is indium. Okay. Here PN junction is when a p-type semiconductor is suitably joined to the n-type semiconductor, the contact surface is called PN junction. When p-type semiconductor and n-type semiconductor joined each other by using any suitable technology, okay, this technology we have see we'll see afterward. Okay, that means when p-type semiconductor and n-type semiconductor joined each other, that joining portion is called PN junction, because there is a junction, there is a junction of P type and N type. Okay, junction, the joint place or the crossing place is called junction. So here the joint place of P type and semiconductor N type semiconductor is called PN junction. Okay, now let us see the formation of PN junction. Okay, how the PN junction format or produced. Okay, first of all, PN junction is fabricated by special technology. One common method of making PN junction is called alloying. Okay, remember the technology by which we produce PN junction, one of the technology, common technology, that is called alloying. Okay, now see what is alloying. In this method, a small block of indium trivalent impurity, okay, is placed on a n-type germanium slab. Okay, as shown in figure. In figure 1, okay, in figure 1, okay, there is a n-type germanium and an indium which is tetravalent for producing p-type semiconductor. Okay, then the system is then heated. This system then heated to a temperature of about 500 degree Celsius. Okay, Celsius. The indium and some of the gallium melt to form a small puddle of molten germanium indium mixture to shown in figure. When the temperature is given to this, then the indium melted and makes a puddle or a liquefied indium in the n-type germanium. Okay, then the temperature is that allowed, and then the temperature is then lowered and puddle begin solidified. Okay, under proper condition, the atom of indium impurity will be suitably adjusted in the germanium slab to form a single crystal. The addition of indium overcome the excess of electron in the n-type germanium to such an extent that it creates a p-type region. That means what happened? First of all, we place a indium in the n-type germanium. Okay, then we heated this system, the two material. after heating, okay, about 500 degrees Celsius, what happened? The indium and some part of germanium mixed and liquefied, okay, and then after lowering the temperature, after lowering these liquid indium and germanium mixture solidified and makes a this makes a p type. How? Now there is a tetravalent indium are there, and the free electron inside the germanium, here germanium is overcome by the holes in the uh, indium, the number of holes in the indium, and it became a p-type semiconductor. And so this is the way by which p-n junction created, because it 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 is became a p-type semiconductor, and one is a n-type semiconductor, and this junction is called p-n junction. Okay, here the p-type semiconductor this much, okay, and this is n-type semiconductor. This is the junction by joint place, okay, and this junction is called p-n junction. After in coming classes we have discussed this p-n junction briefly. Okay, thank you.